All right,
Can
there's
you use anyone you want?
you can use any angle, yeah. So often you might have more information than you need, and it's interesting because when grade 10 or grade 11 students see a right angle triangle where they know both angles, they freeze because they're bogged down by choice. There's too much choice. I don't know what to do. But yeah, just pick an angle and then go with that one. So I've asked you guys to use the sine ratio to find x one way, and then the cosine ratio to find it another way. So basically using each angle one time, and we should get the same answer. And then when you guys are in the wild solving triangles, when you guys have more info than you need, you won't freeze up. All right, we'll keep the cam on for this one. I got the anime hair going today. I think I'll do maximum work for A and then do our minimum work for B. So in both cases, you're given the hypotenuse. But if you want to use the sine ratio, that's using the angle of 56, where what you're looking for, that side is the opposite side. And again, I'm going to show max work for this first one, and you might benefit from showing the max amount of work, or you might feel comfortable enough. So sine 56 is just a number. Make a proportion, solve the proportion. And hopefully, I know I talked to a lot of you guys yesterday. There's kind of a shortcut. Sometimes what you want is on top. Sometimes what you want to find is on the bottom. When what you're looking for is on top, we're just multiplying. So we do 12 times 0.8290 and then divided by 1. Like 9.95. Did you guys get that? About 9.95? And it's centimeters. So we should get the same answer if you decide to use the other angle, in which case the side you're finding would be the adjacent side to 34. So I'll wait just a quick second while some of you guys try finishing that off. I'm going to show the minimum work for this one. I want to see what you're putting in for, I want to see what you're setting up for your ratio. And I want to see what calculation you're putting in your calculator. But then I'm okay with you just giving me an answer. So this the variable's on top, so we're just multiplying by 12. 12 times cosine 34. All right, that's the minimum amount of work I want to see. At least that. It should give you the exact same answer, right? 9.95. All right. So later today, Monday, Tuesday, Wednesday, Thursday, onwards and onwards and onwards. Whenever you guys have options, you guys know you just got to pick an angle to work with and go. Don't worry that there's multiple choices. Okay, you guys good with that?
Yeah.
Don't freeze up when there's choice. Just pick something to work with and go. Because as you can see, it doesn't matter. Same answer both ways. All right. Just to make sure you've got nailed down the language of an angle of inclination or elevation, can you guys do the problem on the back while I pass around the next thing? There is one on the back, right? Like round to 10? I don't really care. I'm a holistic marker. I'm a process guy.
So like if it's
Do you have like 10?
No, I just put 9.9.
Perfect. You showed the right, if you have the right process, I'm happy. Now, if you were building a bridge, I would keep a lot of accuracy if I was doing building a bridge or trying to solve world hunger. Keep as much accurate. Those are important things. Keep accuracy. We're in grade 11 math class. Process is okay. All right, let me pass around the next. It's a beautiful looking document. It looks like many of you guys are actually done this one. Now, I like drew like the actual physical diagram of a kite. I'm not sure what kind of kite that is, like a box kite or something. I actually think it's called a box kite. Yeah, kite flying enthusiasts that want to actually admit it. It's okay. I play disc golf, so I have a dorky hobby too. Um, yeah, but you guys have to decide where to put what. So like the string would be your hypotenuse. So hopefully you figured out that much. I told you we're finding the vertical height, but I think those are things I would have expected you guys to make this diagram. And the angle of elevation, 62 degrees. Remember, that's always from the horizontal upwards. And I think we're just using the sine ratio here. What variable did you guys pick for your kite? Did you just leave it as a question mark? Did you use an H? You use an X? X is fine. I'll use X as well. And I will do the minimum work here. We're in grade 11. We don't need to show. We don't need to take 5 minutes of work to do every SOHCAHTOA problem. We'll be moving beyond that. So opposite over that, and we're X is on top, so it's just multiplying 20 times sine 62. Whatever that is. About 17.7 meters high, and we'll just call that a wrap. All right, quick warm-up for you guys today. It wasn't meant to be a hard warm-up, but I did want to do something like one to make sure you guys were good when you're doing like solving a triangle problem and you have choice. Just to make sure you guys know, you just gotta just gotta pick a choice and move forward. Okay, anything you guys want to chat about before we go on to today's stuff? All right. So I have chosen to split the SOHCAHTOA review up into 2 separate days instead of combining to one. So if you're finding that this is coming back and you're having a good time, then just view that as a positive. Help out your friends who it's taking a bit longer to come back to. Just enjoy knowing what's up while you can. All right. We're going to look at a second type of right angle triangle problem today. So here's the motivation. Now, I don't know if this is true about wheelchair ramps. I just made up this fictional problem. But to be up to code, we're going to say our wheelchair ramp should have a 5-degree angle. It can't be too steep, but it also can't be too shallow, or else it's going to take forever to zigzag up. We're going to say 5 degrees. But I'm not sure if you've been out in the wild. It's actually hard if you come across I know we have kind of a crude one out front. It's kind of hard to actually get a protractor out there and measure an angle of elevation out in the wild. So we can actually measure the rise and run of a wheelchair ramp to tell if a ramp's up to code. Now, I've provided a huge step-by-step outline for, in this case, how we can find an angle using SOHCAHTOA. And then in a couple questions, we'll remove the structure and talk about minimum work to show. But what you guys should do, I've told you guys in this question, we're dealing with opposite and we're dealing with adjacent in this question. So I've told you guys that. In practice, you guys can label your sides or just make a mental note of what they are. But in this case, it's opposite and adjacent. So in this case, we're using the tangent ratio. We've decided on the tangent ratio. So the opposite is 1.05. I'll tuck that in here. And the adjacent is 12. And then this is where we kind of start our process. The tan of theta, I'm not going to write out its opposite over adjacent. I already have that there. I can plug in what I have. The opposite is 1.05, and the adjacent is 12. So this is like yesterday. We start off with the ratio, we plug in what we know. But unlike yesterday, this is different. So yesterday we had a proportion to solve. You cross multiply. This is not one of those situations. It's a bit different. How do we solve this one? Well, 1.05 divided by 12 is just a number. For this one, can you guys just find what that decimal number is? Yeah, it's kind of tiny. But can you guys follow my advice here? This one's exact, but in practice, can you guys just do 4 decimal places all the time? It'll never fail you. So what you guys did yesterday was, for example, I think we did, the first one was like 30 degrees. Yesterday, you guys were given like an angle. Yeah, I think you were given an angle, 30 degrees, and I know we did tan yesterday. And on your calculators, punching in tan 30 gave you 0.577. So given an angle, you can find a ratio. This one's different. This one, you actually have the ratio, and you want the angle. So then how do we work backwards, given decimal, find the angle? Everybody did this last year. You should all have a calculator of your own that you know how to work. But I told you what to do. We're going to use the inverse tan button. So for you people, if you were wondering last year...
Excuse this interruption. For all students who are going on the Canada's Wonderland trip, could you please meet in the bear pit now? Thank you.
Must be nice. Hope it rains all night for you. Check out the video. I'm recording. Make sure you know what's going on this weekend. I kind of did. Have a good time. You guys in 3U will know that means inverse now. But yeah, can you guys find that button in your calculator? You'll have to press shift or second function. And let's make sure we get the same thing. So shift, tan, what's our 1.0875? I got very close to 5 degrees. Hey guys, if you're going, just go, please and thank you. Kinda teaching a lesson here. You guys get 5 degrees? Nod and smile. If you didn't get 5, I'm gonna tour around the room right now and make sure that you got 5 degrees. If you weren't sure, I'll help you figure that out. So get the ratio, get the decimal, and then inverse sine, cosine, tan. Can you guys try this one? Ryan's back on the job. Needs to determine the angle that his conveyor belt makes with the ground. He can only make certain measurements, but he can't use the tangent ratio, or he needs to use something different. So can you guys choose on the appropriate ratio and follow the structure that I provided? I'm going to do a tour. If you didn't get 5 in the previous one, you flag me down, and I will help you make sure you know how to get the angle. This is your chance. All right, I guess y'all got 5. So that means we can kind of start accelerating the process here. All right, so label your sides, or at least make a mental note. Here we are given the hypotenuse and the adjacent. Okay, so this is not a tangent problem. This is a cosine problem. These are things you guys should just be doing in your head, really. They don't need to be written down, but you can write them down if you want to. So this problem doesn't involve the opposite, but our adjacent is 25, our hypotenuse is 34. We'll go top right here. And we are using, and now we start with what we did yesterday. Write out the ratio you're using. If you want to write the definition, cosine is adjacent over hypotenuse, you can do that. But I'm okay if you guys just plug in. 25 divided by 34. I will show you minimum work in a second. For now, I'm just going to get the decimal and write that down. .7353 if you round correctly. But the nice thing is if you round it incorrectly, you're still going to get an accurate answer because we kept lots of accuracy. So we use cosine inverse here. The angle that gives that cosine ratio is about, I'm going to go to 1 decimal place, 42.7 degrees. Did you guys get that too? All right. It's finding angles with SOHCAHTOA. I know you guys did this last year. It's probably, in my opinion, even easier than finding sides. There's no proportions, no figuring if it's multiplying, dividing. But the big idea, you guys find angles using SOHCAHTOA by using, and this is a word that 3U people know by now, but for the 3M people, we're using inverse functions. So on your calculator, it's these buttons. It's the sine minus 1 button. It's the cosine minus 1 button. And it's the tan minus 1 button. Okay? Yeah, but for 3U people, those are the buttons that undo sine, cosine, and tan. They're the inverse functions. All right, so now that you guys have 2 examples here with a ton of structure and showing you what to do, we're now going to remove the structure, crank out a few more. Again, if you're finding today easy, just treat that as a good thing. We'll just get this done, and then you'll be rock solid for Monday. All right. So again, in practice, we won't have the structure. I'm going to kind of reduce the amount of work that I show over the course of these next 2, and then get to be what the bare minimum expectations are. So you guys are asked to find angle T in this one. Can you just, I'll give you guys a second to start out, decide on the ratio to use. I'm going to do my attendance while you guys start that. I'll pause recording here. All right, and we're back. Which ratio, somebody who hasn't helped out yet in a while? Jesse, what ratio do you use for A? Cosine ratio. Perfect. You can label these or not. I'm not your dad. You can do what you want. But yeah, we're given the adjacent and hypotenuse. So what I would do if I was solving this problem, I would write this. I would start with cosine of t is equal to the adjacent side 1 over 2. I would do 1 divided by 2, which is 0.5. And then I would write this. T equals the inverse cosine of 0.5. And then my calculator will spit out an angle. And I believe that's 60 degrees. All right. Put a box around it. So one interesting fact here, the cosine of 60 is exactly 0.5. We're going to explore, the 3U people anyway, are going to explore why that's exactly 0.5 on Monday. And you're going to learn the exact values of a few other angles, sine, cosine, tan. So some brand new stuff. All right. We're finding V in this one. I wanted to find V because it uses a different ratio than T. Somebody different, what ratio do you use for finding V, angle V in the second one? What do you think, Julian? You think sine as well? You're correct. Hypotenuse, opposite. Now, I'm going to show you guys what I would consider to be minimum work here. I want to see which ratio you're using. We're using sine. The sine of angle V is equal to 3 over 10. What I would consider minimum work is just doing things all at once. Your calculator can do this all at once if you just plug in sine inverse of 3 over 10 using brackets. You don't need to do 3 divided by 10 and get a decimal. It'll do this all at once. Just using brackets. I think, at least on mine, when I do sine inverse, actually I have to put in the brackets myself. And then 3 divided by 10, close the bracket. It spits out the angle for me. In this case, about 17.5 degrees. Did you guys get 17.5? This is the minimal work. And in fact, moving forward, once we do enough of these, if we're slamming out a bunch in a lesson, I'll probably just do this amount of work. But this is what I'd like to see. How we doing? Are things coming back from last year? You doing okay? Right. It's possible I could have condensed yesterday and today into one lesson, but I erred on the side of going a bit slower. All right. This is a question like the warm-up, where we want to find angle A, but I've given you all 3 sides. Now, you guys aren't going to get bogged down by choice when you face these in the wild. You guys are just going to pick a ratio to use, and because it doesn't matter. For example, if 25 is the opposite side here, and the long side is the hypotenuse, 54, that makes 48 the adjacent side. Then if I was to use the sine ratio, so sine of theta is 25 over 54. And then to get theta, we'll be doing inverse sine. And then I'm just going to use 25 over 54. I don't think you need to get that decimal. I mean, 10 years ago, when not everybody had a display calculator, maybe we get the decimal, but you can punch that in exactly as you see it. You can get the angle using sine. About 27.6. You know what? For the sake of I actually would like to use. Well, it's theta in the diagram. I was gonna say I could use a, but it's theta in the diagram. It's fine. You guys say 27.6. All right. So can you guys repeat the process? Just do the same thing with cosine and with tangent, and convince yourself that it doesn't matter which one you choose. So then, for like the 3M people on Monday, when you guys are doing an assignment based on this stuff, kind of catching up to speed, you'll be able to help your friends out and say, just pick a strategy that works. That doesn't matter which ratio you use. So 48 over 54, completely different. It's going to be a completely different decimal, different ratio. But if we do cosine inverse of 48 over 54, it's going to give us the exact same angle. So again, it's a bit of overkill on how many of these we're doing, but we're convincing you guys that when you have more information than you need, just pick. It'll work. I'm 99% confident this will give me the same angle, and it does. Did it really? 27. You guys get 27.3 about? Okay. So it's an excellent talking point. It gave us a slightly different angle because a 48, 25, 54 triangle isn't perfectly a right angle triangle. It might be more like 48.1 or 53.9 or something. But you guys convinced it more or less gives you the same angle? Okay. It's good too because, maybe next week when we're all doing a common assignment, you pick one way to do a problem, your friend picks another way. Your answers should line up pretty well, but they might be off by a decimal place or two just due to picking different sides to work with. And finally, tan is 25 over 48. Should be around 27. All right, I'm kind of curious what this one gives now. Second tan, 25 divided by 48. Yeah, 27.5. Perfect. Yeah, so great talking point. You guys okay with that? You and your friend, if you use different methods, you're going to get the same answer. You might differ by a decimal place or two, but that's okay. So we've addressed that here. All right, and then the review skill we're developing, reviewing, solving triangles. Here is now a triangle you'll be able to solve completely using this tool added to the mix. Now, for this first one, and I can turn you guys loose now because I've fully coached you through how to find all the unknown angles. But you guys notice here, we're finding R first. We could have found Q first, right? We have enough information to find the other angle. It's just we're picking a strategy. So I told you guys, find R first. Once you have two angles, you can find the third because they add to 180. And I've told you guys here, since you have two sides, use the Pythagorean theorem. I've done a lot of work for you here, but in the second one, I'm just letting you guys go. I haven't provided any structure. You guys just pick a strategy and carry it out. Okay? Oh, we're going to have a lot of time to practice today. That's okay. It's Friday. So if we're dialing in on R, let's see, adjacent, 6 is the opposite, 6, 11, 6 over 11 equals 5, 4, 5, 5, shift 10. I want to do Q. So that'd be 61.4, right? For a Q. Did I do something wrong? More blank stares than usual here. 6 divided by 11. Inverse tan. 28.6. Subtract from 180. Am I crazy or are you guys crazy? It's equal to that, right? Oh, why didn't you guys tell me that before? You guys just looked at me like I'm an idiot. And now if you'd like to check for yourself what would happen if you found Q directly. This doesn't take a lot of time. Note, and we have space here, so why not? If you do the inverse tan of 11 over 6, so for angle Q, the opposite and adjacent just flip, you should get the same answer. You do, 61.4. All right, and then 36 and 121. It's too late in the day for me to do that. 157, which makes the hypotenuse like 12 and a half or something like that. Yeah, about 12 and a half meters. All right, we've solved the triangle. Can you guys try, and I'll pass around some more practice. Can you guys try the next one? When you have a right triangle with two sides, more or less, you're kind of locked in with the strategy. You do have some choice on which trig ratio to use. But you know what? Actually, once you guys find, and I might go crazy on this one too. Once you guys find an angle, you could use the SOHCAHTOA for sides to find the hypotenuse. I'm going to resist the urge to do this one. I'm going to let you guys finish it completely, and then I'm going to do my own strategy and see how we do. All right, you guys have options for practice. You just got, you've got a bunch of triangles to find an angle for. Or on the back, you've got a few more of the more complex problems. This is in review mode, so if you find this easy, you can crank them out. That's good. We'll spend a little bit of time in class today. Mastering the skill. 3 people will be ready to go on Monday. Sort of it. Yeah. Remember with the Pythagorean theorem? That's like often squared. So when you square root it, it should be fine. Yeah, you're good. All right, so most of you guys, I'm happy with how things are coming back to you guys. I think the second semester people, that might be, we'll see. It'll be even longer for them. But which side did you guys find first, or angle? I mean, Guess anyone find angle A first? Mackenzie, you found angle B first? Well, guess what? I'm going to find angle A first then, just to be different. So I'm going to start with angle A, just to show you guys it doesn't matter. So angle A, my 20 then will be my opposite, and my 16 will be my adjacent. So the tan of A is equal to 20 over 16. So A will equal the inverse tan of 20 over 16, whatever that is. That would be 1.25. You guys get 51.3 for A? All right. Now for B, I could use the tangent ratio again and find angle B that way, but I think it makes more sense just to subtract from 180. Minus 90, minus 51.3. I can mental math. 38.7. Okay. Now here's where I'm going to go crazy. I think you intelligent people were like, I have two sides, I can find the hypotenuse using the Pythagorean theorem. But maybe you're on your unit test or you're just doing some practice at home, and for whatever reason, you're having a hard time pulling back that skill. But possibly SOHCAHTOA is still in your mind. Check this out, guys. I'm going to find the third side using SOHCAHTOA. I'm going to pick angle A to work with. I know that the cosine of angle A is equal to adjacent over hypotenuse. I know you guys use Pythagorean theorem. I'm just doing something different. I know angle A now. It's 51.3 degrees. And I know its adjacent side is 16. The hypotenuse, I'll just leave as AB. And then I think in yesterday's at least a lesson, not many of these where we were dividing came up. But when we have on the bottom and you apply cross multiplying, it'll look like this. It'll be 1 times 16 and then divided by the cosine of 51.3 degrees. And we should get the same hypotenuse. Of course, improvising always works when you're teaching a class. You should always improvise. 25.6. All right, see? You Pythagorean theorem people, I would say you guys probably use the most efficient method. But I just want to show you, there's many, many pathways to solving a triangle once you get more information than you need. So you people at home, hopefully you use Pythagorean theorem, and then checking with me, just realize the same answer. I'm going to end the video now.